All right, this is the installation guidance video for the 126 volt 30S1P fast pack. If you're watching this video, either you're just watching it on YouTube or you found it through the product page or through the QR code in the included documentation sheet in the package that you ordered. Either way, they're all going to circle back to the same video, and that is this one right here. This is the higher voltage DIY/VESC Onewheel battery pack system that is making its way into the product catalog for the Board Garage. The distinct features of this battery kind of encompass what you're looking at. Unlike every other battery in the DIY VESC/custom area, this one is not just built into a cell holder frame for the sake of holding the cells for assembly and separation. The frame completely encapsulates both the cells and the conductors to create the most rigid structure that you could put into this sort of battery shape. It doesn't just hold the cells in place, it runs the entire length of both halves of the pack, forming a completely rigid structure, and combines with the support splines that run through both halves of the pack, both top and bottom, to create a shape that resists all distortion, both torsionally and laterally. And so this pack does not flex. This pack is a solid brick, and the cells and conductors from the welded nickel to the wiring is running through keyed channels guarded by those splines, which removes any pressure and compression from any of the joints in the entire pack. It's sort of inescapable if you're filling a battery box with batteries, especially if you're using something like a cush pad, a urethane pad, that the battery is going to see the rider's weight. You are essentially, for the most part, standing on a battery if you're using anything like a soft foot pad. That's just part of how it goes. What this does is it assumes with higher voltage comes higher speed riding and more eventful potential crashes, impacts, compression, and vibration, and it removes any of the structural risk from the delicate parts of the battery itself in an effort to survive and thrive through racing, high-speed riding, and those potential crashes. That is the whole goal of this. To that end as well, the BMS, which is traditionally in a one-wheel shaped device, mounted at the rear on the slanted surface of the battery enclosure. It's moved from there for this particular design, and you'll see that instead we have hard mount posts that are built into the frame of the battery. And so the same frame that's protecting the entire pack is also holding the BMS via a hard mount onto the side of the battery. What that does is, once this battery is sitting in the box, it's sort of floating in open space. It's not contacting any edge of the box. The only point of contact for this are those mounting posts on the frame itself. In addition to that, there's an air gap below this, and so while fast charging, which can get you this battery from 0 to full in less than an hour, about 45 to 50 minutes, depending on the cell being used. This will, of course, heat up at that higher charge current, and so with the air gap and isolation between this and any other sensitive material in the battery area, you're gonna have less of an effect of the BMS's heat on anything else that might actually be affected by it. All that being said, this is going to be the guidance material for installing it into the battery box. Now, the fast pack can fit either the original Torque Box 1, which is this one right here, or the Torque Box 2. They essentially will fit more or less the same, with one exception between the two. This was meant more so to fit into the original Torque Box, and so the only additional step with the Torque Box 2 is to add another layer of foam padding on top to make up the slight extra bit of vertical gap that you have between this and the bottom of the lid. The goal is to secure this battery in place so that it does not move, because this needs to be located in a particular part of the box, which is what we're going to talk about now. If you have the three-piece combo, you are going to get three things. You are going to get the battery pack itself, you are going to get a configured and conformal coated X-Lite V4 32S BMS, and you are going to get the fast charger, which is a 126 volt 6 amp charger, which will take this battery from 0 to full in about 45 to 50 minutes, depending on the choice of cell. Also included with the other items is this little bag of extra parts. In this bag is going to be the mounting screws for the BMS, an XT60 connector to make a dovetail adapter for the charger. The charger by default ships with an XT60 end, so you can adapt it to whatever plug you're going to use for whatever front enclosure box you're going to use, or you could just request a specific plug type and polarity and pin wiring, at which point that XT60 won't matter to you. And of course some heat shrink if you're making an adapter with this XT60. What I usually do is I get my tools ready, I get everything ready, and if I have parts bags and stuff, I will just dump it into a very visually apparent container. So this is a 3D printed screw tray, and I've got the 4 mounting screws right there. The 4 mounting screws are M2.5, but they're a particular type, so you can't just use any screw. I will link to the exact screw that this is. You can get it on McMaster Car, but it is an M2.5 5mm length plastic thread cutting thread, because the mounting posts are plastic and these grip into plastic. It's very similar to if you've ever opened up an actual one-wheel box and you've screwed down that little tail light retainer clip. That is a plastic screw thread into plastic screw threads. So if you ever just uninstalled or changed the rear tail light in a one-wheel battery box, it's the exact same type of screw as that. So that's what these are. For that, you will need a size 1 Phillips. So in this case, I have a size 1 Phillips bit right here, or a standard size 1 Phillips screwdriver. You will also notice on the underside of the pack are these 2 things. This is double-sided adhesive, 2 inches wide. There are 2 of them. This keeps the battery pack in one spot, and along with the lid compression ensures that this stays located where it should to protect the BMS and keep everything working the way we want. So let's move this aside. We're going to install it into the Torque Box 2. So moving everything else aside, we are going to reference the install approach in the Torque Box 2. As I mentioned, the approach is more or less the same, except in the Torque Box 2, since it's slightly larger, you will add an extra layer of foam up on top, which is in essence just an extra amount of the same kind of foam that's under the lid of the Torque Box itself. Now, the first thing to do is to mount the BMS to the battery pack. I recommend you mount the BMS to the battery pack before you plug anything in, because generally, even though the BMS is conformal coated, don't want to go poking around with a screwdriver and screws on a live circuit board. So my recommendation is to screw it in and mount it before you plug it in. For mounting the BMS, you will of course need the screws, your screwdriver, your pack, your BMS, and a hot glue gun. I'll explain why momentarily. So when looking at the pair of the battery pack and its BMS, you want one particular desired outcome. This thing to mount on there securely, successfully, and not have it move ever for the life of the battery. And in order to do that, you will need the hot glue gun for one specific reason. And so, before plugging anything in, you're going to want to visually match up the BMS mounting posts with the mounting holes. And what I recommend you do is to secure one screw on the driver and use that to first locate where the BMS is going to be. You will be able to sort of drive the screw backwards a bit once you see the tip of the screw insert into the post. And once you feel it sort of click off of the first catch in the thread, you can then slowly start to screw it in. Do not tighten it down completely. Leave all of the screws loose until all 4 are in. Then you will slowly screw them down until they are snug. Not crazy tight, snug. You don't want to strip out the screw threads. It's not easy to do, but if you wrench it down like you're screwing in a metal screw into a metal thread, you will damage it, and then you'll have to send it back to be fixed, and that really sucks, and so you should just avoid that. So we've got one corner screw in. Do the same thing here. Get the screw into the post. Back it up enough. Oops. Once it's seated in the hole, back it up just enough to feel a bit of a click where it drops off that first thread, so you know it's catching. Then you slowly drive it in until you see it starting to go into the post. Give it another turn or so, maybe a half a turn until it's loose, and then leave that the way it is. Grab the next screw. Try not to lose these. Then, bottom mounting post. Visually line it up and do the same thing. You can turn this on the side. You go like so, carefully, don't kill the wiring on the corner. Back it up a little bit, feel the drop off from that thread, make sure it'll catch, and then slowly thread it in. The threads are heat formed, so on these posts, you're not actually cutting the threads. Threads in the posts are already formed with a heated screw, and so the threads will match, they will catch as you expect any screw thread to catch, and then you sort of slowly just guide it in. And now we have our last screw here. I include a few more, so if you do drop one, it's not the end of the world, just don't drop all of them. Once again, if for some reason you've lost all of them, you can either just reach out and I'll send you some more, or you can follow the link in the documentation area and just get more of them. And then the last screw here, you're going to do the same exact thing, very carefully because you are around wiring. Back it out until you feel it sort of catch, and you can see it happen. I'll do it again. You'll watch the screw, if you're adding a little bit of inward pressure, it sort of drops off that shelf of the start of the thread, and that's how you know you're in the thread, so you don't cross-thread it and damage anything. And then you very slowly sort of just screw it in. And now all 4 screws are in there. BMS is kind of loose and rattly, and this is when you're going to tighten them all down. Now, you want to snug them down, not death grip them down. And so once you start to feel any resistance, give it like a hair more, and then just stop. Okay, so we go in, you'll feel it snug, you'll feel resistance, give it like a hair more. And I'm talking about use like, 2 fingers on the driver, give it a little bit more. And then when you feel it with like these 2 fingers, actually stop moving, stop. Same thing here. Okay, give it a little bit more, hair past snug. Don't wrench it down. This is not, no, don't do this, all right? Don't, like, I'm an electrician, I know what I'm doing this. This is not, no. These are M2.5 screws in plastic threads. This is not the most delicate thing in the world, it's not, but this is not ham fist, Hulk strength type stuff. Don't do that. 2 fingers on the driver, that's all you need. There we go, just past snug, give it a little bit more, I feel it stop, and we're good. And now your BMS is secure. The next step to make sure that this does not move is simply to prevent these screws from backing out. Any screw can back out over time with enough vibration. That's just how it is. That's why thread lockers exist. However, we're not adding any thread locker to these. What we are doing is locking them in place with the hot glue gun. Here's how you do it. It's not actually that hard. All right, so we've swapped lenses, we've zoomed in, and we've propped up the battery and BMS onto something here so we can make it more clear. Now we're just going to do the 1 screw as reference, this one right here. We have visually checked that this thing is both screwed down secure and that the screw is indeed snug. Now, hot glue gun has been heating. Just very quickly, the hot glue gun has been heating. This particular one, the glue that I use the most for basically everything is Gorilla Glue sticks. Their hot glue holds really, really well, and it holds well over time, at least as compared to other ones. So that's what I'll be using. This has been heating up on the high temp setting. Don't use low temp. Low temp for stuff like this is essentially useless. Low temp is for delicate stuff, arts and crafts, things that actually get damaged from a higher heat. None of this will in this particular case, and so this is on a high temp setting. This has been heating up for a while. That way we know that the glue is not cold, it is actually at the high temperature, and make sure you have some area where you can squeeze off a bit and make sure that the tip of the hot glue is primed to actually apply the glue to where you want it to go. And so we are going to focus on this particular screw right here as the reference point. So let's go ahead and zoom in. Let's go ahead and set our focus to that particular area, and then we will apply glue to this screw. So the approach you want to have, just like everything else, is geared towards the desired outcome. This is screwed down like all the other screws are, and so the goal is to stop this from rotating out over time under vibration. And the way we're going to do that is we are going to start with a bead of hot glue at the actual indentation on the head of the screw where the driver goes in. So that Phillips head cross, You want to start there with the glue. Then you want to move to the outside of the head of the screw, pass over the PCB, and onto the mounting post. And that's essentially it. It's one single bead of glue on the screw head itself, then over the shoulder, then over the PCB, onto the mounting post. And you're going to do that for all 4 screws. So let's go ahead and do that now. And so we will start here, make sure that this remains in focus. Start here at the head of the screw and dispense the glue onto the head of the screw, and then over the side, and then onto the mounting post. And just clean that up. And that is it. And you can do that for the other screw as well. Let's reset our focus. All right. Start at the head of the screw. Make sure some of the glue gets into the actual driver area, over the shoulder of the screw, across the PCB, and onto the mounting post. And that's screw number 2. And you're going to do this for the other 2 screws here at the other end, near the XT60 connectors. And once you have all 4 screws in that way, try to reset some focus here, I apologize. Once you have all 4 screws done, wait for this to cool and completely solidify, and then you should be good to go. Moving on from there, once the BMS is secured down, you can now plug it in. Now, the way I usually do this sort of thing is I start from the far end of the balance connectors, work my way up the cell series, which I'll show you in a second. And then the last thing I plug in is the XT30, which is the terminals of the pack. And so the farthest connector is actually this temperature connector. And so we will go ahead and plug that in one. It'll click in because it's a JST-GH, which is a little latching thing, latch. Next thing is the largest one. It'll also be the longest wired connector. And that goes right there. You will probably see an LED on the BMS turn on. It won't do that for every connector. That's totally fine. Then should be the next temp sensor. Oops. And these will kind of locate themselves because they're of different length. And so the next size is also the next length, which is this one. Do make sure that they are actually the matching connector. Don't plug in the wrong size. You'll see the LED go in again. There are only 2 temp sensors in this pack, and then you'll have the last one right here. In that particular case, there won't be an LED that goes on usually, and that's fine. So now these are all there, and that's okay. Next and last is the XT30 connector right here. It goes into there. The pack has a female XT30, which goes into the male XT30 with the black wire facing the center. So that's where that goes. It's keyed with a flat and a round spot, and so it really only goes in one way, but do visually check before you actually plug it in, which is important. In the DIY world, especially when you're dealing with such high voltage, all of this stuff is dangerous, period. You should be assembling things slowly and intentionally and, looking at the thing you're plugging in before you plug it in. So, we're checking to make sure that the keying is correct with the flat spot lining up, because that's the positive, and the round spot with the black negative is on the center. That's what we're doing. This is keyed, but I'm sure you could force it in the wrong way and cause something to explode, which would be bad. So let's not do that. Okay? And then I believe the LED should go on again, both of them, and press that all the way in, and that's it. Now you have a single pack BMS unit, and it can be placed in the box. So let's do that now. Now I've gone ahead and mocked up a cable harness into this box. Obviously it's not connected anywhere. And so this is really just to show the wire placement. Now, when I build a board, I will mock up the wire placement before I actually mount anything anywhere. So I'll put the pack in there. I won't adhere anything down. I won't attach anything or commit permanently. In a torque box too, do make sure you're sticking that extra stuff in there with the screw-on plug and the venting disc. You got to close up the box. You can't forget that stuff. I understand a lot of people do it last. You do it however you want to do it with your sniffers and all that stuff. Just make sure you actually seal the box, because not sealing the box is bad. That being said, I've mocked up the wiring where I recommend the terminations go. And so this is the discharge connector. It's the big XT60. This will loop around the corner like a common meat pack or something like that. It'll loop around the corner here and it'll sit about halfway up the pack. And so that's where I have this. This is going directly to the VESC. The charge port connector, which is this small male XT30, is going to loop around the pack and connect right there because it's going to that thing right there. So we want to make sure that's landing where we want it to land. This little bit is for the tail light. I don't have one in here, but it's just to demonstrate. So wherever your tail light wiring would end is where you would terminate the tail light wiring to the rear. Usually for me, it's about in this area, more or less. Lastly, since this is a VESC connected smart BMS, it's an X light, we also want our CAN bus connector. It's 4 wires, 5 volt and ground to wake up the BMS when you turn the board on, and CAN high and CAN low, which is the data. In this particular case, we're not going to loop it around this way. This was an idea that I got from a New Jersey rider, Garrett, so thank you for that. He actually looped it this way around the tire side lip, and it connected right there. Wire ends up shorter, that's all good, and since we're biasing this pack towards the tail end, you have plenty of space in that area for these wires. And so this is going to loop around the tire side area and then connect into the CAN area, CAN bus connector that way. So that's how this is laid out. I'll usually use some blue masking tape to sort of move this over off to the side. You can do that. A lot of the times it'll just sort of hold itself, but you want this sort of thing open and free. And so you have your battery and your BMS all attached together, and that's all good. You want to mock this up and practice before you sort of commit with adhesive, because this stuff is really hard to get off. It can come off, you can take the pack out, but it really sucks to do it. So mounting the battery in the box while the position in a torque box 2 is not crazy critical, it's pretty damn important, so pay attention. So before you remove this stuff, locate it. You can hold on to it like this, just don't yank it. So if you're just sort of lowering it in, do that. Here's where you want the battery to be. All right, let's look at it this way. Tire side, tail side. The pack wants to be biased tail side and cable harness side. All right, the torque box and the torque box 2 are for the XR platform, which means the power cable is here. All right, now I'm looking this way at the tail to the nose. If you do it this way, you are now looking tail to the nose. All right, so the nose is over here. You want to bias it to the tail and to the power cable. So this way, and this. If you're looking at the nose of the board from the back, it's towards you and to the right. All right, back and to the right. Back and to the right. Or if I'm this way, tail side, cable side. The reason is the BMS is going to sit right here and you want this empty space. That's the whole point. All right, so let's carefully lift this out. What you would do now with the BMS installed, what you would do is remove the backing paper of the double-sided adhesive and slowly lower it in. Here's how I do it. Remove it, transfer hands, close to the bench, don't hover this so you drop it, and just butt it up against there, right? Butt it up against the cable side. Make sure it's like this. And then very carefully, while holding this, is just a guide, right? You're not yanking it. And just plop it in. Now, it probably won't be perfect. That doesn't matter. But let's do it again. Lift this up slowly. Oops. All right, we've removed, you could also do it this way. We've removed the backing tape, or the backing paper of the adhesive tape, biasing it on the corner, towards there, and towards the tail. All right, this corner right here, biasing it there. Doesn't have to be perfect, just bias it there so you get the extra space. And then while it's biased to that corner, slowly plop it in. And wherever it sits is wherever it sits. You'll notice that once it's biased in that corner, your BMS now has all the space in the world. The connector's not even close to touching anything. This wiring's not encroaching on anything. You got all the space in the world here for just open air. And that's what you want. All right, so look at how it's biased. If we flip it over, you can see that it's filling in this corner here. Notice the power cable, corner's right there. BMS has all the space in the world over here. Look at all that space. And it's the same thing for the torque box 1. I'll go get it. Torque box 1. You get a little less space, but frankly, it's the same. All right, so removing the backing paper off of the double-sided tape. Our power cable's right here. You can see the cable gland right there. So we're biasing it here to this corner. All right, that corner. Here we go. Carefully, sort of lower it in. Boom. That's it. You get a little less space, but quite frankly, you still get all the space you need. All right, so this wiring will just smoosh in there. And there you go. If you have a little bit extra wiring that's sort of encroaching on this lip, a little bit of Kapton tape right there, just to make sure it doesn't pinch when you close the lid down. But the BMS has space. The connectors in the BMS are not touching any surface there with that corner. You just get a little less space than you would with a torque box 2. That's really all it is. You get a little less space, but you still have the space you need. And so remember, tail, corner. Last time on the torque box 1, because it's more restrictive, bias it to this corner. All right, so this way and back. Here's another way to do it. Lift it up a little bit and just bias it with gravity to that corner. And then just drop it in. There you go. Didn't even have to use this as a guide. Sort of hold it that way so it falls naturally into that corner, and it's exactly where you want it to be now. Once you do that, you now have to do your wire management. Everything should land where it lands. Let's just pop this out. Go get the torque box 2 because that's where our wiring is. Last time we're demonstrating it, let's just even hold the box. Try it that way. All right, biasing it here to this side and the rear corner. And there we go. That's even easier, actually, now that I think about it. Don't have to deal with this wire. All right. This side, back corner, pop it in. Boom. So now that we got that, bring our wire back around. Discharge connector right here. All right, so that's matching up nicely right there. If you have a tail light, you now don't have to worry as much about it because it's here and the BMS is not touching it. So you can put a bit of fish paper right there just to guard it if it's got a sharp heatsink or whatever it is you're doing. I don't know. Tail light will plug in right here. Charge connector will schmagoop around this corner, land right here, plugging into the charge input for the BMS, no problem. And our CAN bus is gonna go ahead and loop around and connect itself right here. Blammo. Biff bam wham, river jam jam. And that is essentially it. If you have wire that really wants to sort of sit on this lip, what I usually grab is Kapton tape, as mentioned. I'll link to this in the description and the documentation as well. Straight up Kapton tape. This is really good for sort of making sure that your wiring is sitting where you want it to. So you want a little bit of it sort of like right here, although you probably won't need it for this wire. But over here, stick a little run of it right there, just to make sure it stays in place and is being managed. If you want to keep this wiring off of your tail light, a little bit of Kapton tape here. Done. And that's it. Now with the torque box 2, I did mention you're going to need some extra foam. All right, there you go. So I'll just include this in the box with the battery. Why not? So use this if you're installing this into a torque box 2. What I would do, you know what I would do? Before you commit to sticking this down, I would do all my wire management, make sure that everything is, sort of managed, taped down, and just put this on top and do a dry fit of the lid. On the torque box too, you do have a little extra vertical height, and so I'm pretty sure you're gonna need this to make sure that this stays down completely. So I'm gonna just cut squares of these, and I will include them with the 3-piece combo. Since I'm including all the other parts anyway, it just makes more sense to do this. So I'll just include this, not a problem. So torque box 2, got this all, taken care of. Extra foam on top for a little bit of vertical hold, and then that should be good to go. As with any DIY installation, do make sure that every step you take with assembly, you are assessing the step that you are taking before, during, and after you take that step. So when you're placing the battery in the box, pay attention before, during, and after you've put it down in the box. Don't make a mistake doing it. If you make a mistake, quickly reverse. Same thing with this. Make sure your wire placement is correct. Make sure everything is managed. Add the tape if you need it, and assess after you've added it. Is the lid going to fit? Is it going to fit enough that this secures it in place? Are we adding the foam to the proper location? And when putting the lid down, is it securing it at the desired compression to make sure that this is secure? If it is, fantastic. Continue on to the next step. And that's really sort of the procedure for installing anything into this type of project, but especially for something like this, where location in the battery box is key. I do hope that was helpful. Feel free to reach out via email if you have any other questions about this. This sort of comes in and out of stock as I make batches of them. I don't like taking pre-orders anymore, so I just don't. I make a batch of something, I list it for sale, it sells out, I do it again, rinse and repeat. And so if that's the case, feel free to sign up on the store page for notifications. I send out email notifications when there's a new product, a restock, whatever the case is, and then that should be good to go. Appreciate your viewership. I very much appreciate your support of the shop. Thank you so much. I do hope that this ends up being a useful tool for you in your desired outcome for your perfect personal one-wheel build.